Okay, so today we're going to change one small thing, and that is instead of our rectangle being vertical, our rectangle is going to be horizontal. So you're saying to yourself, why would I bother doing that? Well, I have an example that illustrates why you should probably be aware of how to handle that to make your life a lot easier. Okay, so here we go. Horizontal rectangles, same idea, same application, same setup, except everything's going to be in terms of y, not x. And every representative rectangle is going to be horizontal, not vertical. Stuff we did yesterday, or the other day, I keep saying yesterday. It's the block schedule. I'm kidding. Horizontal rectangles, do all the stuff we did with horizontal y instead of x, and then you should be able to get a job or get into college. One or the other, I don't care.
Right now?
No, not right now. You should be able, there's no time frame attached to that. It's just at some point, you should probably be able to do one of those two
I'm
things.
gonna job this summer.
Yeah, you don't have to, you just gotta get in. Right, then you can do, you go on a cross-country killing spree, I don't, whatever. Become a serial killer, become homeless, you do whatever you want. It's not my position to tell you what to do. I'm trying to give you some guidance. Okay, so let's look at this example. You'll notice, well, let me ask you, what do you notice? Bingo, not a function, why?
That's beautiful. I like how you do.
Good. Why else is it, or how do you know it's not a function? Bryce, loud and proud so the recording can pick that up.
Vertical line test.
Does not pass the vertical line test. But just because those aren't functions doesn't mean we can't solve for the area. If we did it based on the method that I showed you on Monday, we would get this train wreck. Okay, there's 3 different regions there. And setting that up can be rather challenging. I'm going to show you what that looks like. But we're not going to solve the problem that way because that's not what this lesson is about. Okay. So first things first. Let's use red. If we do this region over here using that vertical rectangle, we're going to do top minus bottom. But the problem is that top minus bottom is from a function to itself. So we go back to this guy. If I solve that for y, I get y equals what? No. Gotcha. Bingo. Now that seems trivial. Why does it matter? Plus or minus x? It matters very much so. When we talk about functions, if I solve that function for y, because it's a class based on functions, we would only take the square root of x, that curvy top part of the side parabola. But because this is a weird problem, we all of a sudden have to take the negative part also. So this guy here is the square root of x. This one down here is the negative square root of x.
The red one.
Correct. Thank you. Should be using the other function. But you get the idea. Okay, so I'm going to end up subtracting the function from itself, which would be twice as far. You also look at the blue one. If I look at the blue function, when I solve that for y, it's going to get really ugly. So I don't want to do that. I'm going to use a different technique here. Get rid of this. Okay. Now, you might say to yourself, why can't I just force that? I like the vertical rectangles. I want to use the vertical rectangles. However, you're going to see problems where you don't know how to solve for y. Both of those functions, the red one and the blue one, you are all smart enough to know how to solve for y. Assuming you include the plus or minus, and you can grind this problem out. However, you will see later some problems that don't allow themselves to, that's horrible English, you can't solve for y. Okay. So we're going to do something different, and that is we're going to use a horizontal rectangle. The sharpest move to make that yellow because it's a little hard to see, but hopefully you can see the yellow rectangle. Yes?
More or less.
Good enough. Obviously that's not going to be top minus bottom anymore. How long is that yellow rectangle? I'm sorry, what?
It's the difference, it would be the blue function. I wonder the blue function minus the red function, but I don't think that's right.
It's the other way around.
So it's the
Red function minus blue function, correct. How tall is that rectangle?
dy.
Beautiful. That's the only thing that changes here. We're working with y values instead of x values. Instead of talking about how tall the rectangle is, using top minus bottom, we're going to talk about how wide the rectangle is. It's not top minus bottom, it becomes right minus left.
Why is it right minus? Oh, because x values.
Vertexes are 0, we just know that area.
Okay, does that make sense?
Would you just take the positive square root or like the right minus stuff? 'Cause it would-
Save your question. See if I answer it in solving the problem. Okay. First things first, I'm not going to trust the graph. I'm going to solve for those two black dots. How did I solve for those two black dots? I set the functions equal to each other, and I find that the points of intersection are at y equals 2. Because we're working with y as our variable, everything is done with respect to y. Where am I taking rectangles from? I'm starting with the first rectangle up there at positive 2, and I'm accumulating rectangles all the way down to negative 2. The other element would be what we already talked about, and that's the right minus left. That's our function. So we find the area of the rectangle, click, 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 by doing that. And that's the right minus left. The right function is the y squared. The left function is the 2y squared minus 4. Don't forget those parentheses. Es muy importante, see? And the height of that rectangle is dy. Very, very, very small. Infinitely small, but not quite 0. And you see why, that if you got the stuff on Monday, this stuff is not that big of a deal. Now I just need to add up all those yellow rectangles from 2 to negative 2 as an accumulator, and we get that. Now you're saying to yourself, how do I, let's suppose I wanted to fn int that. How do I fn int that? Say again? Say again?
Oh, just say it's an x and a y.
Yeah, just put in x's instead of y's. You could use y's if you want, you just have to make sure to put a dy in there at the end, not a dx. If you put in y's into the function and you put a dx at the back end, it's going to cause a whole bunch of problems. What I would do is just type it in as the integral from negative 2 to 2 of x squared minus 2x squared minus 4 dx. You'll get the same answer. Problems. Okay, now, I would not do the problem this way. I would change one small thing. I would go from 0 to 2 on the integral. What would I have to include? Wait. Oops.
Oh. Would you multiply it by
Yeah, multiply by 2. Why would I do that? Well, if I'm going to fn int it, it doesn't matter. If I'm going to grind that puppy out by hand, 99% of the time it's easier to plug in 0 than it is to plug in a negative 2. So whenever possible, I'm going to recognize a symmetric function and just do half of it. Problems, questions, concerns? Are we good? Any issues? Is everybody? Sure. Okay. Okay. Good. Let's see. Now my filter's working. Okay, top minus bottom if you're working with vertical rectangles in terms of x. Right minus left if you're working with horizontal rectangles in terms of y. No other options. Some of the problems you'll look at can be solved either way. Part of the trick that will make your life a lot easier is if you are able to recognize which one will be more efficient. Like I said in the example in this one, you could do it using vertical rectangles, it's just gonna be really ugly. Whereas if you use horizontal rectangles, it's one integral, done, life is great. Okay, we're good? Excellent, that's one done. Let me stop this.
Exit here, so I come over here.